Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. Welcome to the Astro Guy podcast. I'm your host, Wayne Zool, and this month we'll take a look at what's up in the November sky. Once again, there's a lot going on in the skies this month. We have a meteor shower, the gas giants are ruling the evening skies, and there's a comet that may reach naked eye visibility this month. We'll also explore the constellations Aquila and Auriga in this episode. The most famous meteor shower to grace November skies is the Leonid meteor shower. As the name implies, the shower radiates from the constellation Leo the Lion. While the shower peaks on the 17th of November, there will be a waxing gibbous moon in the sky, only 2 days away from being full, making spotting meteors difficult at best. But if it's clear, the best time to try to view them will be in the hours before sunrise when the moon has set. Because of the phase of the moon this year, from very dark skies you might be able to see 10 or more meteors per hour. So dress warmly, have a comfortable place to sit, and enjoy the show. Even though the shower peaks on the 17th, Leonid meteors can be seen from November 6th through the end of the month. To look for Leonids, locate the head of Leo the Lion. It's easy as it looks like a backwards question mark. The shower's radiant is near the star Algeba, near the middle of the question mark. You want to scan the sky about 30 degrees from the radiant to try to spot the most meteors that you can. Approximately every 33 years, the Leonids can appear as a storm of meteors, with 1,000 or more meteors visible per hour. The last Leonid meteor storm occurred in 2001. I had the pleasure of observing this from the very dark skies in Springfield, Vermont. We had set up at 2 a.m. with just lawn chairs, and things started out slow, with a meteor appearing every couple of minutes. Then they began showing up more rapidly. At one point, I counted 6 meteors in just 1 second. As the sky began to brighten by the soon-to-be rising sun, the meteors were streaking all across the sky. Everywhere you looked, there were meteors, all seeming to radiate out of Leo. It was an amazing sight to see, and there were reports that for a couple of hours, the ZHR was in the thousands that year. So why does this shower periodically have storms? Meteor showers occur when the Earth passes through the orbit of a comet whose orbit has crossed the Earth's. As the comet is spewing material out from its interaction with the Sun, that material disperses, but travels in the same orbit as the comet. So when the Earth passes through that cloud of material, some of it will hit the atmosphere and burn up, creating the meteors that we see. Most of the meteoroids are tiny particles, the size of a grain of sand, so they mostly burn up high in the atmosphere and don't make it to the ground. The parent comet of the Leonids is comet Tempel-Tuttle, which has a 33-year orbital period. The comet was first observed in 1699 and was recognized as a periodic comet in 1865 by Wilhelm Tempel and Horace Tuttle, hence the name Tempel-Tuttle. So definitely try to see the Leonids, as there are occasionally brighter meteors associated with this shower. At the start of November, the sun sets just before 6 p.m., so by 6:30 you should be able to spot bright Venus low in the western sky. On November 1st, Venus doesn't set until 8:14 p.m. In a telescope, Venus will show its phases, which are similar to the moon's phases. On the first of the month, Venus will be 49% illuminated, but by the end of the month, it will only be a crescent, about 31% illuminated. Try to spot it, and watch how the phase changes over several days or weeks. The gas giants again are ruling the November skies. On November 4th, Uranus will be at opposition. This means the Earth will be in between the Sun and Uranus, in a straight line. Uranus will rise when the Sun sets and will set when the Sun rises. It will also appear at its largest and brightest for the year around the 4th of the month. It will glow at magnitude 5.7 in the constellation Aries, the Ram. You can spot it with binoculars, and through a telescope it will appear as a small, bright, greenish-blue disk. Even though Uranus is at its closest point to the Earth, it will only span less than 4 arc seconds. Remember, 1 degree is 3,600 arc seconds, so to see anything more than a star-like point of light, you'll need a telescope and medium to high magnification. At the beginning of the month, Saturn will be due south at its highest point in the sky just before 7 p.m. To the naked eye, Saturn will appear as a bright yellowish star that doesn't twinkle in the constellation Capricorn. In any telescope, you should be able to see Saturn's beautiful ring system. On the other end of Capricorn, you'll easily spot bright Jupiter. Jupiter appears as an orange-yellow star that doesn't twinkle. In the beginning of the month, Jupiter will be at its highest altitude in the south, about 33 degrees above the horizon. In binoculars, you should be able to spot the 4 Galilean moons near Jupiter, while in a telescope, you should be able to make out the equatorial bands on the planet and the Great Red Spot when it's facing the Earth. Jupiter rotates on its axis every 9.925 hours, so in an evening, if you're watching it long enough, the Great Red Spot should rotate into view. On November 7th, the Moon will be 5.5 degrees to the right and slightly below Venus. This will be stunning without any optical aid and will be nice in low-power binoculars as well. In the early morning hours of the 19th, for most of the eastern part of the country, the Moon will go through a very deep partial lunar eclipse. The Moon will be in the constellation Taurus, the Bull, and will be about 6 degrees away from the naked eye open cluster M45, also known as the Pleiades. It will be interesting to see how many individual stars in the Pleiades you'll be able to see as the eclipse goes on. Lunar eclipses are perfectly safe to look at, and usually look best with the naked eye, binoculars, or a telescope at low power. A lunar eclipse occurs when the Moon passes through the Earth's shadow. At the Moon's distance, the Earth's umbra, or darkest part of the shadow, appears larger than the full Moon, almost 1.5 degrees across if you were able to see it. The Moon passes through the umbra, but only 97% of the Moon will be covered by the umbral shadow, as the Moon doesn't pass through the center of the umbra. First contact with the penumbra, the lighter part of the shadow, occurs at 1:02 a.m. However, the penumbral shadow is very difficult to see, but after a while you might notice a slight dimming of the Moon. The real show begins around 2:19 a.m. when first contact with the umbra occurs. It's very likely that you won't notice it for several minutes, but 5 to 10 minutes after first contact, you should see a part of the Moon getting darker as the eclipse goes on. Over the next 3 hours and 28 minutes, the Moon will slowly pass through the umbra, with mid-eclipse occurring at 4:03 a.m. During mid-eclipse, the Moon will be 97% covered by the umbral shadow, with only 3% near the south pole of the Moon extending into the penumbra. The color of the eclipsed Moon can range from a very dark brownish red to a bright copper color. Several factors impact how the Moon will look, including the amount of ash, smoke, and dust in the Earth's atmosphere. We won't know how deep the color will be until it's observed. After mid-eclipse, the Moon will continue to pass through the umbra. It's interesting to watch the shadow, as it's one of the ways that ancient astronomers were able to realize that the Earth is spherical. The moon will exit the umbra at 5:47 a.m. Eastern Time. If you're on the West Coast, first contact with the penumbra will occur late in the evening on the 18th. If it's going to be clear out, this is worth waking up early for. Just bundle up, as November mornings can be chilly. If you're watching the eclipse with a telescope, you can actually watch the edge of the shadow as it slowly moves over the moon and covers different features. While looking at low power will offer the best views of the colorful part of the eclipse, using higher magnification will let you see the shadow slowly moving. For lunar eclipses, I typically use a 70mm refracting telescope and will swap out eyepieces to see the overall view as well as enjoying more close-up views. Imaging a lunar eclipse can be done with a camera that's mounted on a tripod, or using a telescope as the camera's lens, or projecting the image from the eyepiece into the camera. This last method is tricky, and there are relatively inexpensive adapters to hold the camera, or even your cell phone camera, up to an eyepiece. If you try this method, I urge you to practice it a few days ahead of time, as getting everything lined up is tricky, and you don't want to miss the show while you're trying to get the image on the camera's sensor. To learn more about lunar eclipses, you can visit eclipse.gsfc.nasa.gov/lunar.html. On January 3rd, 2021, a new comet was discovered by Greg Leonard. Comet Leonard is a long-period comet, taking 35,000 years to make one orbit around the Sun. The comet has brightened since our last episode, but not quite as much as predicted. It starts the month around 12th magnitude in Ursa Major and is best seen between 2 a.m. and sunrise. While still only visible in larger telescopes, it should steadily brighten as the month goes on. By mid-November, the comet will be in the constellation Canis Venatici, and at month's end, the comet will be in Coma Berenices. It is predicted that the comet should be an easy binocular target by the end of November, and possibly a naked eye spectacle, as it makes its closest approach to Earth on December 6th. Mornings will prove to be the best time to look for Comet Leonard. You can get finder charts and updated magnitude observations on the skylive.com/comets. The skylive.com is a great resource, is free, and very easy to use. Moving out of the solar system this month, we'll explore the constellation Aquila, the Eagle. In the beginning of the month, Aquila is high in the southwestern sky at sunset. Its brightest star, Altair, which comes from the Arabic phrase al-Nasar al-Tair, which translates to the flying eagle, shines brightly at magnitude 0.76, making it the 12th brightest star in the night sky. You may know Altair as one of the 3 stars that make up the summer triangle. As far as stars go, Altair is very interesting. It is one of the closest stars to us, at a distance of only 16.73 light years. Altair is 1.8 times more massive than our Sun, but it is 11 times more luminous. Using interferometry, observations have shown that Altair isn't spherical. It's actually flattened a bit. Interferometry is a process where an object is observed by 2 telescopes in different parts of the world at the same time. Their images are combined, which creates interference patterns that make 2 relatively small telescopes act together as one very large telescope. In a future podcast, we'll discuss interferometry and how astronomers use it. So why is Altair somewhat flattened? Because it is large and rotates very quickly. Our Sun takes about 25 days to make one rotation on its axis. Altair, on the other hand, makes one rotation every 8.9 hours. Like many stars, Altair is part of a multiple star system and has 6 smaller stars orbiting it. Its companion stars are faint, all being between 10th and 13th magnitude. A bit later, on November evenings, the constellation Auriga, the charioteer, climbs in the eastern sky and offers us many treasures to explore. While the constellation is supposed to represent a charioteer, to me it looks a bit like a squashed pentagon. The southernmost star in the pentagon, Elnath, is actually in the constellation Taurus, but is on the border of the two constellations. Auriga's brightest star is Alpha Auriga, more commonly known as Capella. Capella is the 6th brightest star in the night sky, shining brightly at magnitude 0.08. Capella, which lies about 43 light-years away, is actually a quadruple star system. Capella has a companion star, and there is another double star that orbits Capella and its companion, making up the system. The companion stars are all very faint, with the brightest being magnitude 10.3. Capella is a similar type of star to our Sun, except that it's a giant star and is about 12 times as large as our Sun and about 2.5 times as massive. Auriga has a plethora of deep sky objects, and some of the best open clusters are within the constellation's borders. In particular, there are 3 objects cataloged by Charles Messier in the 1700s. Messier, or M36, M37, and M38, are all easy to find and easily visible in binoculars and telescopes. In fact, if you're using certain binoculars, it's possible to see all 3 clusters in the same field of view. To locate M36, also known as the pinwheel cluster, start at the star Mahassim, Theta Auriga, and sweep halfway to Elnath. In binoculars, the cluster should be toward the top of your field. It's about 2 degrees above the midpoint between Mahassim and Elnath, if you think of that line as the bottom of the pentagon. M36 is made up of about 60 stars, and of those, about 40 are visual in amateur telescopes. In binoculars, the cluster will appear as a fuzzy patch about 1/5 of a degree, or 12 arc minutes across. With a telescope, you should be able to resolve some individual stars in the cluster, especially around its center. The brightest member stars are around 9th magnitude, but the total glow of the cluster is magnitude 6.0. Use low magnification and spend a bit of time trying to resolve the member stars. Try increasing the magnification to see how that impacts your view, but don't go too high. M36 is a relatively young star cluster and lies about 3,900 light-years away and is 14 light-years across. Imagine having 60 bright stars so nearby. If Earth was orbiting one of the cluster's stars, the night sky would be filled with dozens of very bright stars. If you were to sweep back to the midpoint between Mahassim and Elnath, and swept about 2 degrees below that line, you should see the bright open cluster M37, also known as the salt and pepper cluster. This cluster is larger and brighter than M36, and it is one of my absolute favorite open clusters to observe. Discovered in 1764 by Charles Messier, this cluster of more than 150 stars glimmers at magnitude 5.6. M37 lies 4,200 light-years away and is 25 light-years across, which at that distance makes it appear 23 arc minutes across, or just over 1/3 of a degree in diameter. This is an easy object in binoculars and will appear as a large fuzzy patch with a few faint stars standing out. From dark skies with a telescope, you should be able to resolve several stars in the 9 to 13th magnitude range. Near the center of the cluster, there are two 9th magnitude stars that are on the end of a chain of 10th and 11th magnitude stars. This cluster is best observed at low to medium powers and will provide you with interesting views as you explore it. The last open cluster we'll look at this month is M38, known as the Starfish Cluster. Made up of about 100 stars and lying at a distance of 3,900 light-years, this diffuse open cluster is 12 arc minutes or 1/5 of a degree across. To locate it, go back to the midpoint of the bottom of the pentagon and go back to M36, then continue on in the same direction about 2 degrees and you'll be looking right at M38. In binoculars, the cluster will be a dim patch, and with patience, you may be able to resolve a few stars within it. With a telescope, several individual stars can be observed, with several forming straight lines in different directions, leading to the starfish name. Once again, low powers will provide you with a more pleasing view in the eyepiece, but you should explore to your heart's content. If you're under very dark skies, you can try to locate the Flaming Star Nebula, about 2 degrees southeast of M38. You'll need a telescope at very low magnification, hopefully at least 8 inches of aperture, and a nebula filter will help. This is a challenge to see, as there are several bright stars between 4th and 6th magnitude in the foreground that can wash out the nebula. However, you may be able to pick out brighter sections of the Flaming Star Nebula. This is a great photographic target, but will likely require very long exposures to show it well. While there is much to see in the November skies, hopefully this will get you motivated to go out and look and explore these wonders for yourself. So go out and enjoy the night sky. That's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Thank you again for listening, and may your skies be clear. As always, carpe noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.